Today we're going to talk about cola and how to light it, so if you ever render cola, it will seem believable. Cola is a liquid and it shares a lot of characteristics with water, which I'll be using to compare to point out specific traits of cola. Refraction, reflection, absorption, and scattering all happen inside cola to varying degree. I'll be going over how cola is different than water in each of these aspects. Four simple things to keep in mind when rendering cola or any kind of liquid is refraction, which is the direction of light changing when it enters a different density. Reflection, which is the light bouncing off an object, bouncing off a reflective surface well enough to send a copy to your eye. Absorption, which is light being trapped and not sent back to a certain degree and usually makes the wet object appear darker. And scattering, which is a lot of light being thrown in every direction and causes a stark white appearance in a lot of things like foam and clouds. So what is cola made of? Cola used to be made with the cola nut that grows in a species of tree in Africa. Nowadays, artificial flavoring is used in almost every cola drink except naturally flavored cola and some energy drinks. Cola soda is made differently depending on the brand and which country it was made in. In the US, cola is made with sugar, while in Mexico, cane sugar is used. I personally like the Mexican version, and it comes in a 3-liter bottle, not a measly 2. Caramel coloring soda is what gives the soft drink a dark, sometimes black, looking brown hue. It absorbs a lot of light despite being watered down, and when it's watered down even further, usually with ice, the color appears brighter and more brown. Caramel coloring is used primarily as a coloring agent and a flock inhibitor. A trait of cola is that cast shadows can fall on the surface of cola. Clear water, like in the image bottom left, can reflect back a perfect image so well it's hard to tell where the trunk meets the water. Murky and polluted water lets shadows fall on them because there are opaque particles in the water for the shadows to fall on. Cola is transparent, but not completely. If put into a scale, cola is closer to clear water in the image below than the muddy river on top. The shadows would be weak and only visible up close. Another trait of cola that differentiates it from water is foam. Foam in soda is carbonation trapped in sugary liquid. Foam in the sea is air trapped in water that's full of fats, lipids, and other organic matter that's been dissolved. Foam typically throws light everywhere and is an example of scattering, though because of the coloring agent it appears brown and it can look white when the cola is watered down with ice. If you're thinking about cola eruption after seeing foam, here's how it works. There is carbonation injected into soda to give it the fizzy bubbles soda is known for. When you open a soda, you can hear some carbonation escaping. You may be thinking, why doesn't it all come up at once? That is because of surface tension. The water molecules form a mesh, trapping all the carbonation, and it leaks slowly. Eventually all the carbonation will escape unless you cap the bottle, and that will cause the soda to go flat. No more bubbles. What happens when you drop a Mentos in a Coke is that it breaks the surface tension, letting the bubbles have more freedom to move. As the candy sinks down to the bottom, its uneven and rough candy coating gives bubbles lots of places to gather and makes the bubbles come free much faster. It all starts to rise to the top, and you probably know the rest. Thank you for watching my presentation, and if you'd like to know more about the properties of water and other things from my presentation, please browse through the links in the description below.